Let's dive right into our first example. Remember, in the Hack the Box interface, we need to note what the IP address of the machine is. The IP address you may be looking at is likely to be different than the one I have here on the screen. So please make sure you copy the correct one by clicking on the IP address here on the screen. Jumping back into Pwnbox, we're going to clear our terminal and we're going to begin exploring several tools we can use to enumerate the application running on this machine. The very first thing an attacker is going to do, no matter what kind of target they are trying to enumerate, is going to be running a scan using a tool called nmap. Nmap literally stands for Network Mapper and has about 1,000 ways to configure it, many of which you can look up online or view countless tutorials and online courses that will teach you how to use it. In this course, we're going to stick to the basics. Let's start by typing the word nmap into our terminal. If you hit enter, you can see some of the built-in documentation to the CLI tool. As you can see, there are lots of scripts and flags that we can associate to using the nmap executable. But we're going to keep this simple. We'll start by typing the word nmap, followed by a -A and a -P lowercase n, followed by the IP address of our target machine, which is 10.10.10.242 in my case. And remember, your IP address might be different. Now you can hit enter, and nmap may take several minutes to run. In this case, the scan was pretty quick. Let's review what nmap has told us. Keeping in mind that nmap is a network mapping utility, the output on the screen describes any ports and services that it could detect running on the target machine. Specifically, it found port 22, as well as port 80, and it tried to roughly identify what services are running on each of those ports, namely SSH running on port 22 and HTTP running on port 80. Neither of these findings is particularly surprising because port 22 would typically be used for a developer or the owner of that machine to connect to it to do various administrative tasks. And port 80 clearly indicates that there's a website being hosted on this server. Knowing that there's a web server running on this machine, let's quickly open up a browser to take a sneak peek. Parrot OS has Firefox built into it, and we can find that icon here in the upper left corner, where we can simply click on it and then type in our IP address, to directly access the website running on this server. To be clear, this is exactly how the internet works, although typically we would access a website using a domain name which pointed us to the IP address of the machine hosting that website. We've simply taken a shortcut to access that machine directly. While we're here, let's practice enumerating the site. The first thing an attacker is going to do is going to view the source code. Scrolling through the source code of this web page, we can see a lot of CSS, which is mostly going to be uninteresting to an attacker. There could be some inline scripts to catch our attention. And in fact, we can see that this particular website uses a window.parent.postMessage API. While that finding in itself isn't relevant to this specific example, it would be a great piece of information for an attacker to note. Thinking back to all the different ways that a cross-site scripting attack might execute on a web page, seeing window.postMessage should definitely be something that raises a red flag. Continuing through the rest of the application source code, we don't see a whole lot in here that's that interesting. We do see a link to a third-party piece of JavaScript. We do see some other JavaScript embedded within the page, but there's nothing really here that's going to catch an attacker's eye. The next thing an attacker might do would be to look more closely at the nmap's scan results. Things like what version of Apache might be used to host this website. All an attacker has to do is search for Apache 2.4.41 vulnerabilities to see if anything obvious comes up, as the latest version of Apache 2.4 is likely to be much higher than the version hosting that particular site. Perhaps there are other security patches available or publicly known exploits that an attacker could use to abuse this web server. Again, in the case of this specific example, Apache is not the problem. The use of nmap and the ability to view the source code to enumerate all aspects of the technology used to build a website, as well as the source code itself, are things that every attacker is going to do. There's another tool we should be looking at called nikto. Nikto is another CLI tool built into Kali Linux and Parrot OS as a way to help enumerate a web application. Similar to nmap and other CLI tools, there are many flags and options you can pass to this tool that are outside the scope of this course. We're going to type nikto with a --host, and then we're going to type http:// and followed by the IP address of our target machine, 10.10.10.242 in my case. Hitting enter will let this script run. Nikto took about a minute to run, so we can review the results. Nikto is going to tell us some of the same information that nmap or perhaps other automated tools might tell us, but it's also going to highlight some very specific information about websites or web applications. Point your eyes to the first two line items found by nikto, namely server and the retrieved x powered by header. We can see that nikto identified Apache 2.4.41 is the version of Apache running on the server, and that is what nmap also told us. However, the second finding is more interesting. The powered by header tells us that this server is running a version of PHP, specifically PHP 8.1.0-dev. Now, if you didn't know every PHP vulnerability off the top of your head, something that might have caught your attention is the -dev in this version number. And if you've ever used a development or pre-release version of any software, you're aware that it likely contains lots of security holes. The first thing an attacker is going to do is Google this version of PHP to see what vulnerabilities may exist. And what do you know? The very first result here in Google is from exploit.py, a website that you'll become painfully familiar with throughout the rest of this course. Clicking on this search result, we can see a link to a write-up explaining how PHP version 8.1.0-dev is vulnerable to a kind of attack known as remote code execution. Since this vulnerability already has an exploit written, we can easily copy this code to our Pwnbox instance to then begin exploiting the vulnerability on our target machine. To do that, we can hover over the download button and click Copy Link Address. and then flip back over to our PwnBox instance. Using a utility known as wget, we can instantly download the executable Python script to our local machine by running wget-O, giving our local file a name. I'm calling that exploit.py, followed by a link to the file that we want to download from exploit.py. Hitting the Enter key, we'll see that wget saves that locally, and I can run ls-al and see exploit.py here on my local machine. From here, we can run python exploit.py. This will prompt us for the target machine we wish to attack. In this case, it's the IP address of the machine we were just looking at. http://10.10.10.242. Again, your IP address might be different, followed by the Enter key, at which point we have a remote shell to the target application. If you're not familiar with reverse shells, this might seem a little mysterious, but typing in a command like id will make this much more clear. So let's recap what we just learned. The first thing an attacker is going to do is to run an nmap scan, trying to determine what ports and services are running on your machine. There's a lot of powerful things that nmap can do, and lots of information that it can find, and Hack the Box has lots of resources for you to learn as much about nmap as you could possibly want. Once an attacker knows that there's a website being hosted on that particular machine, the next thing they're going to do is to simply open a browser to go and inspect the application to learn as much as they possibly can about it. That may include looking directly at the source code to see if there are any interesting tidbits about the application that they might use in their attack. In this particular example, neither nmap nor the application's source code gave an attacker all that much information. So from there, an attacker is likely going to use other automated tools to scan and enumerate the application. The next tool we looked at was called nikto. And nikto is an open source web application vulnerability scanner. One of the first things that nikto told us was that the version of PHP running on this target machine was an outdated development version of PHP 8.1. Clearly, the only thing we had to do was Google the version number of PHP being used, and the first thing we found was an active exploit written in Python. With a few quick keystrokes in our terminal, we were able to download that exploit and run it locally, which gave us shell access as the user James on that machine. James may or may not have been an administrative user on that machine. Certainly an attacker would continue enumerating on the server itself as a means to further infiltrate and escalate their attack. But for the sake of our example, we're stopping at the HTTP layer. The moral of this story is not to use outdated and vulnerable components, which is one of the important lessons taught to us by the OWASP Top 10. It's also a valuable lesson in continuing to monitor all of the third-party resources that are used to build and host an application. If this was your application, you'd better stop what you're doing and go patch that version of PHP ASAP. So we've learned a couple of CLI tools, and we've learned the basic enumeration pattern that an attacker is going to use when they look at a web application. Let's take that knowledge and move on to exercise number 2. Let's go.